Hi guys. So we're still dealing with infinity minus infinity. We've seen how to do it when we factor. So we saw the problem where we factored out the greatest common factor. We saw the problem where we factored out just a random thing to get rid of that infinity minus infinity form. We saw how we could use our trig identities. And now we're going to do one that involves lns. So to plug in here, we'll just remember that the graph of ln x looks a little something like that. So ln, as we approach infinity, as x gets bigger and bigger and bigger, my ln is also getting bigger and bigger and bigger. So when I plug this in, I get ln of infinity minus ln of infinity, which is indeed infinity minus infinity. Now we have some log rules that tell me that if I have log of a over b, then that equals to ln of a minus ln of b. And this is the rule that we're going to use here. Our rule for multiplication is this: ln a times b is equal to ln a plus ln b. But note that this one will very rarely be used in infinity minus infinity because the chances of that actually giving an infinity minus infinity and not infinity plus infinity or negative infinity minus infinity is very small. So usually we're going to be using this first log rule here. And when I apply this log rule, I get the limit as x approaches infinity. So I'm going from right to left here of ln of 2x plus 1 over 2x minus 3. Okay, so now when I plug in, I end up with ln of infinity over infinity. And I want to point out here that my problem, my indeterminate form, doesn't actually involve the ln. My indeterminate form is just that thing that is inside of my ln. So what we're going to do, same as before, we're going to take the problem, we're going to take that infinity over infinity and bring it off to the side. So I'm going to call it smiley face here. And we're going to go off to the side and just do smiley face. So here I have the limit as x approaches infinity of 2x plus 1 over 2x minus 3. And so what we're going to see here, we talked about taking the big stuff before. So I could absolutely apply L'Hopital's rule here. But I'm hoping that you guys will get to the point where you could look at something like this and immediately know that the answer is 1. Because you're looking at the fact that we can take the big stuff. So here we're just going to actually take the big stuff. Taking the big stuff. So that we can see that this is actually the limit as x goes to infinity of 2x over 2x. Those things cancel each other out. And my final answer here is just 1. So the goal is to get to the point where you can look at that ln and not have to go off to the side and do this and be like, oh, hey, that's just a 1 inside there. So this is equal to ln of 1, which we know to be 0. And so my final answer here is also 0. Turns out, same as with my secant minus tangent problem, those infinities are the same size. Now, I do want to note that we could have done this with L'Hopital's rule. Limit as x goes to infinity. I'm just going to apply it here. And we would have just gotten 2 over 2, which is equal to 1. But again, our goal is to get fast at doing this so that when we look at that, we're just like, we don't have to like spend time thinking about, well, how do I apply L'Hopital's rule? And actually applying it, we can just be like, that's ln of 1. The answer is 0. All right, guys, so that is it for what we're going to do with infinity minus infinity. I'll see you in the next video for exponents.